Jim Witham, you're the CEO of GaN Systems. Thank you very much for taking the time with me. So GaN Systems has a very proprietary GaN technology named Island technology. What is the difference between your technology and what the other people do?
Yes, Rolf, so GaN Systems uses Island technology. We don't use conventional fingers. The advantages of islands are that you can pack the transistor tighter, so you can make a smaller chip. Smaller chips are good for low cost, but smaller chips also have lower capacitance, so they switch better and you get a better figure of merit. So you kind of win on both fronts.
So are there any challenges with that technologically or economically?
So islands are more efficient than fingers from about 1 or 2 amps up, and that's kind of the power range that people are looking for. We make devices right now from 5 amps all the way up to 150 amps using the Island technology.
So GaN Systems has also a proprietary packaging technology developed with AT&S in Austria. So what is the benefit of that packaging technology?
Yeah, so once you have a good die, you also want to make sure that you get the most performance out of that. And the 2 things in packaging that really kill you are a lot of inductance and poor heat transfer. And so what we did with AT&S is we worked on a system, a package that has no wire bonds, so it's low inductance, and it has lots of copper inside of it to get the heat out. And by doing that, we can get a lot more power out of a given device, so the dollars per watt of a system goes down, and customers love it when you decrease the dollars per watt of their system.
So this morning there was a session at APEC together with Denso, Sonnen, and Supermicro. They were joining you on stage. So what have they presented enabled by GaN Systems devices?
Yeah, it was very nice. In the past APEC, I've been talking about what customers have done with GaN devices, and in this case, 3 customers got up and said what they've done. One in the solar industry, one in the data center industry, and one in the automotive industry. In the automotive industry, it's all about size and weight because you've got to carry it with you. And so Denso's made some very small and lightweight electronics, in this case a DC to DC converter. In Supermicro's case, it's all about efficiency in the data center. Power is the #1 operating cost in data centers, so if you can make more efficient power electronics, it doesn't cost as much to run your data center. And if you can put more kilowatts into the same size of your power supply, then you don't need as many power supplies and you can put more servers in your rack. More servers in the rack means more terabytes from the rack and more revenue from the rack. So not only do you save energy expenses, but you also get more revenue through your assets. So data center guys love GaN technology. In the energy storage area, efficiency is also the key there. When you have only a solar inverter, you're going through the power electronics once. When you have an inverter plus a battery, you also have a DC to DC converter, so you're going through the power electronics twice. So efficiency times efficiency is the power loss, and so efficiency becomes very, very important. Sonnen was able to increase their efficiency by over 4%. So that's more energy that's useful. They were also able to decrease their bill of materials cost by 8%. So you get a better performing system and you save money. It was really neat to hear him on stage saying that.
So earlier this month, GaN Systems announced a 150 amp device. But this is something very new. It's a bad eye device. Tell me, what is this for?
So it's for high current applications, so high power industrial, but really high power automotive. So it's for traction inverters. So we don't package this device because it'll get packaged up in power modules on aluminum nitride substrates and things to be able to really get the power out. Why this is such big news is this is 5 times higher than any other GaN company's device on the marketplace. And so it allows you to get very, very high power into a module and get up to the levels that you need for a traction inverter. So we're working with customers on 225 kilowatt traction inverters with GaN, something that a couple years ago couldn't be done, and people had kind of dismissed using GaN and traction inverters. That game has changed.
On the other hand side, you also launched this month Lowcost and devices. So what are the target applications for these devices?
Yeah, so we did. These are low current, low power devices. We took a second generation chip, so it's smaller than our first generation, so it's more cost effective. And we also put it into a plastic package, which is another cost effective means. And so the combination of those two is a lower price point, especially aimed at consumer applications, kind of in the 25 watt to 500 watt range.
So I know that at PCIM in Nuremberg in May, you will deliver one of the keynotes. Can you give us a little glimpse of what will be, what is the topic of that keynote address?
Sure. In the past, we haven't talked a lot about our industrial factory applications. So my topic's going to be on Industrial 4.0 and how GaN is being used, especially in things like factory motors, to get some of the big economic benefits that we've talked about in the consumer, data center, and automotive areas before.
So, Jim, thank you very much for the interview.
My pleasure. Thank you.